On Wednesday, the 12th of February 2014, just before dawn at the National Corvette Museum, a motion sensor triggered security cameras. 8 rare or unique Corvettes had been swallowed whole. But the distinctive Skydome had been home to iconic cars for 20 years. So why had the ground literally vanished that day? Hey, I'm Tom. Welcome to Why Stuff Fails. This time my special guest is geotechnical engineer Mike Marasa.
So let me tell you a little bit of the story of how they found out about the sinkhole. The alarm went off.
Mike helped to investigate and fix the sinkhole.
The fire department comes in, they show up, they go around the Skydome and they go, holy. How are you this afternoon?
Yeah, very good.
So, without further ado, we'll get into the Corvette Museum. So just tell me how you heard about it and how you got involved.
Well, I had a pretty well-established presence in the area as kind of a ground modification or a soil repair expert. So on the morning of February 12th, I had gotten calls from the museum saying that they had a little issue and wondered if I could provide some input. And so I grabbed one of our structural designers and we went up to the site and prepared for, maybe a couple of hour meeting, and was escorted back to the Skydome.
Yeah.
And was in a bit of shock at the sinkhole inside the structure.
Man, what a scene.
Exactly.
Was that like when you walked through the doors, was that the first time you saw the sinkhole?
Yes, it was, because I had no advanced footage.
Right. I guess there was disbelief, obviously, but then was there a sense of, is this thing still going to keep growing? Has it stopped?
Right. That was certainly something that was brought up, because the way that the sinkhole dropped out, it left places where the floor slab projected out over the sinkhole. So when you're standing on the floor of the Skydome area, you're not sure whether there's anything beneath you or not.
My gosh, was that crazy?
Yes, absolutely. But the biggest threat was the fact that the cavity undermined the center spire by about 40%. So a lot of the center spire was unsupported.
Right, which is concerning.
It was very concerning, and I'll preface by saying I'm not a structural engineer.
Of course.
But it's obvious that the spire is interconnected to the perimeter structure at the ceiling, at the apex of the spire. If the spire had collapsed, it would have breached or undermined the security of the upper ring and could have progressed to other parts of the outer shell, causing a little more jeopardy to the structure itself. So at 6 p.m., we stopped the meeting. I went to Walmart and bought some clean clothes and got a hotel room, because this was going to continue for another day or two.
Brilliant. I love it.
Well, and that's certainly where the challenges started. Essentially, we had 25 to 30 people starting the next morning going, what the heck?
Yeah, I'm not surprised.
First job: rescue the cars.
I want to emphasize that we're in the Corvette Museum. And the fact that we're in the museum, the vehicles that are in the sinkhole are prized possessions. They're there because they're unique, they have a special background, and getting those cars out of the hole was a priority.
Was there an atmosphere, I guess, of just cool, calm activity, or was there like the pressure's on because with the spire and then wanting to get those cars out of there?
I think the best way to describe it is coordinated chaos. Could have been 70 or 80 people inside the dome at any one time, evaluating, taking notes and taking pictures and all of that. Obviously, typical construction attire was required, and we discovered that there were a number of very interested people from the area, non-construction, non-engineering people, that had actually gone to the local construction stores and bought hard hats and safety vests so they could sneak into the site and look around.
And did they get in?
Oh, yeah, until we figured it out.
Yeah.
Certainly the Corvette Museum staff, those guys were all over it. They had, I think, the last of the cars excavated and pulled out of the hole within maybe 3 days.
So why did the floor collapse?
There are so many of these stories all over the US. Quite a few of them were failed infrastructure, whether it be a storm drain or a sewer that had eroded under the road. But was it immediately obvious here what went wrong?
Upon first examination, it was pretty obvious it wasn't a leaky pipe infrastructure issue. It was a geology triggered event.
Yeah.
Considering the geologic setting, it wasn't surprising. The region near central Tennessee and central Kentucky is a particularly prominent place for sinkhole development.
Right.
The largest mapped cave in the world is Mammoth Cave, which is about 20 miles up the road from the museum.
Right.
The bedrock is limestone, which is very soluble in slightly acidic water. So being exposed to rainwater seepage over thousands of years, little by little, the small cracks and fractures in the rock are eroded to form larger and larger void space to the point that they form caves.
Yeah.
Caves that have a roof very near the surface often have roof collapse that results in a sinkhole. It's just a culmination of a lot of time and collapses.
And then it goes.
So it fit geologically to be a sinkhole. The challenge at that point was discovering the limits. And then the museum employed a gentleman by the name of Jason Polk. He was the one guy that was insane enough to actually go into the cave.
Right, I was going to ask about that. So he went down.
Yes, geared up for cave exploration and went down and did a very comprehensive hand mapping of the cave and its structure.
Right.
We took that information and overlaid it with the footprint of the building to see what risk there was for other parts of the structure. That was invaluable to how we proceeded.
So basically, there's a whopping great big cave slap bang underneath the Skydome. How come it wasn't found during construction?
That's a question I've heard about 1,000 times.
Yeah.
Since 2014.
But how come?
Well, there was an engineering study done before the museum was built. Exploratory holes were drilled until they hit what they presumed was bedrock.
Yeah.
The problem was, though, is that although it was 15 foot thick, it was very fractured bedrock, essentially like loose boulders that were interconnected, and they sat there by luck and and nature for thousands of years until they didn't.
Yeah, right. So I guess then the obvious question is, what do you do?
How do you rebuild above a massive cave?
Right. Well, actually, the first thing that we tried to approach during the repair sequence was to stabilize the spire, because that time element was pretty critical.
Could you, I guess in the simplest terms possible, tell me what physically actually had to be done?
We had to get, let's see, I think there were 8 micropiles designed for the spire, but there were 5 that were critical to getting in.
So when you say micropile, what materials and how did they kind of do the job, I suppose?
Right. So a micropile is a small diameter, hence the micro adjective.
Right.
They're a heavy-walled steel pipe that's drilled into bedrock, and that's where the support from the piles comes from.
Over here, I think, if you have a house that's subsiding, it's called underpinning. If your house is sinking, you can do that sort of thing.
Right. The project got pretty lucky. The material availability is slow.
Yeah.
And it could have been 4 to 14 weeks before the first of the pipe showed up.
Wow.
As luck would have it, there was a project in Louisville, Kentucky that had material on site. So that project was put on hold the week that the sinkhole dropped out. So with a little magic, the drill crews and the material were shipped from Louisville to the site.
Right. Without that, then it could have been teetering on the edge there. Everyone's nervous for a lot longer.
That's exactly right.
And how did you know how deep it needed to be? Was that from Jason's exploration, or do you just keep going until you feel like, yep, that's good?
We needed a minimum of, I don't know, I think it was like a 20-foot embedment into sound material in order to develop the capacity to hold up the structure. So in many cases, we were able to find decent material in the 60 to 70 foot range below ground surface. There is one pile that is actually under the spire that is 204 feet long. That was
that's like 2.5 times the depth of the cave. So does that mean that the ground around there was just a mess?
The rock was in horrible condition. It was badly fractured, 1 to 2 foot voids down to this, 175 foot level.
Right. No, there's not just one cave. The ground there's other cavities that are kind of like the other bits of the sponge, I suppose, almost.
Correct. That's very good.
I guess there was a sigh of relief once those micropiles were in place around the spire.
Yes, absolutely. Once the 5th one went in and was secured to the foundation of the spire, it was okay. Now we can start being more systematic about working on the structure, the rest of the structure, and getting things stable.
Yes.
Because we knew how many piles it was going to take to support the structure, but the other piles that would be needed couldn't be installed until after the sinkhole was fully backfilled.
Right. I guess you've got a big pile of rubble that used to be immediately beneath the Skydome that's dropped into the cave. And you can see from the video and the photographs, there's sort of gaps around that I guess just are the entrance into the cave. It's like if you poured something in and it's just going to drop out.
Correct.
It's almost like a plug in a bath that isn't sealing. So how did you come up with a plan?
Well, a very typical approach is to do some injection grouting with a very thick grout to basically replace the void with something that has some structural integrity. The challenge to that was, though, that we had no clue as to the volume of the cave.
Yeah.
So
Just
when you
filling
start,
and filling and filling.
how much is that going to cost? It's, I don't know, somewhere between 3 and 30 million, because we have no idea how big it is.
Yeah.
The,
Crikey.
the insurance guys didn't like that answer.
So, what was the solution? Basically, what did you do?
What they proposed was using sheet piles to block off the openings to the cave,
Yeah.
and then they cut each sheet to fit intimately with the sidewalls of the sinkhole all the way around.
Right.
And they laid them flat and created that false floor to be able to encapsulate the fill going on top.
That's amazing.
They conveyored gravel to fill from the top of the sheet piles to the ground surface.
Okay.
So they had two little vibratory rollers that were remote controlled,
Nice.
running back and forth across the top of the gravel to give it some densification.
Yeah.
That gravel's purpose was to provide a working platform. Period.
Right.
The slab was going to be structurally separated from the ground, independent of any void or fill material that was underneath it.
So that's kind of like a reinforced concrete bridge deck standing on loads of stilts.
So you're exactly right. They become a bunch of stilts that support a slab that is not depending upon the ground to give it support.
And I guess that new floor is as good as, if not better, than what was there before.
Well, it's certainly better because it is supported at a depth well below any any future cave development or erosion within the that limestone layer.
I don't know if they had like an official reopening event.
Well, I mean, I was there for the ribbon cutting ceremony when they reopened, which was a lot of fun, very, very festive. Everybody was really excited to open the museum back up. It was unique from a lot of perspectives, and I'm impressed with the creativity and the willingness of people to entertain non-normal procedures
Right.
to do that.
That's brilliant. Thank you, Mike.
No problem.
Sadly, only 3 of the cars could be returned to their former glory. The others were just too badly damaged. But as for the Skydome, the fix clearly worked. If you visit the museum today, you'd have no clue there was a giant cave beneath you. Once again, a big thank you to Mike for giving me his time, to the National Corvette Museum for the footage, and to you for watching. If you found this interesting, give us a like or subscribe and click the notification icon to hear when new videos are released. That'll really help grow the channel so we can make even more stories with great engineers explaining why stuff fails. And for anyone who's still watching, these are edited down from much longer, more detailed conversations of around 90 minutes. If there's an appetite to see those in full, let us know and we'll find time to post those too. And that is it from me. Thanks again for watching.